Yeah. Hello everyone. Welcome to the session. In this video, I'm going to discuss about wireless network, how to transfer data from one node to the another node, and how to provide mobility to the nodes in the wireless network, and then we are going to analyze some quality of service parameters, namely throughput, delay, control overhead by using this AWK. So let me go to the software, open the terminal, go to the directory, this is my software that is on desktop, that is nsg2.jar. So I'm going to change to the directory that is a desktop. And give the following command: java space -jar nsg2 dot jar, and just press enter. A separate window will get opened with the menu bar, system scenario window about. So under scenario, you just select, you have two types of scenarios here: wired scenario and wireless scenario. As we are working on wireless networks, so I'm going to select new wireless scenario. When you click on this wireless scenario, you are going to get like this. After this, you can select the nodes. So you click the mouse wherever you wanted to get created that node. So I wanted to create that node over here. So its coordinates are 371 and okay 277. Let us note down those values. Like this, you can create as many number of nodes as you wanted. So just a second. Looking for pen. So this is the x coord. 371 is the x coordinate of this node n0, and 277 is the y coordinate of the node n0. So in this fashion we can create as many number of nodes as you want. This information is going to be useful to me. What is the node name and what are the coordinates of this nodes? The coordinate of this node is 371 and 277. So in this fashion we can create as many number of nodes as you want. So whenever you want to transfer data from one node to the another node, the other node must be in the range of the first node, then only the data transfer will take place. So I am creating one more node here. See, automatically a connection is going to be established between the nodes here, whereas in the case of wireless network, explicitly you need to establish a connection between the nodes, whereas in the case of wireless network you just see that the other node, that whatever you are creating, it is in the range of the first node. If it is so, that node gets created and the link between those two nodes will be created. So this is your second node. Its name is N1 and its x and y coordinates are 573 and 286. This is how we can create the nodes in the case of a wireless network. After this, I just want to transfer data. If you want to create a few more nodes, you can create, it is up to you. So let me create a few more nodes. So this second node is in the range of the that is node N2 is in the range of the node N1. So the link has got established between N1 and N2. See, I have created one more node between one more node, namely that is N3. It is in the range of node N1. So a link has got established between this N1 and N3. So like this, for every node there will be a range. So if you click over here, what will happen? Let us see. So a link is going to be established with this new node and the existing node. So by means of that, right, you can come to know that that node is in the range of that other node with which the link established. So this node N4 has got linked with the node N2. It means that this node N4 is in the range of the node N2. So this is how you can create the nodes in the case of this wireless network. So let me record the x and y coordinates of all the nodes that whatever we have created till now. So already have recorded the x and y coordinates of the nodes, okay, n0 and n1. So now I am going to record the x and y coordinates of the other nodes. The 733 and 470, 733 and 417 are the x and y coordinates of the node n2, and 670 and 282. 670 and 282 are the x and y coordinates of the node n3, and coming to this node n4, it has the coordinates that is 942 and 376. 376. And next we will see how to transfer data, okay, from one node to the another node. I already clearly told you that whenever you wanted to, okay, transfer data from one node to the other node, that other node must be in the range of the first node, then only we can, okay, transfer data. So you are known that this n1 is connected to n0, in the sense we can have a data transfer from n0 to n1 or n1 to n0, but we cannot, okay, transfer data from n0 to any other node except n1, because only this node n1 is in the range of the node n0 and the other nodes are not in the range of the node n0. So go to the agent. If you want to, okay, transfer data from node n0 to node n1, then you can make this n0 as a source agent. So I have selected the, okay, agent type as a TCP. You just okay, click on this node n0 and you can attach this, okay, TCP. You can attach that, okay, agent type, that is a TCP. So this is TCP 0 at the sender side. So when the agent type is a TCP, at the sender side, you have to take the agent type as a TCP sink at the receiver side. We wanted to transfer data from node n0 to node n1. So you have to add this agent type, that is, okay, TCP sink, to this node n1. So, and then you have to, okay, establish a link between the agent types at the source and destination nodes. You are known that the source and the destination nodes are n0 and n1. So you have to establish a link between the agent types that are added to these nodes. So I am going to establish a link between this agent types, that is, okay, TCP0 and TCP1. So this is, okay, one data transfer. If you want to have, say, okay, two or more data transfers, you can have. So let us Yeah, let me take say one more data transfer, that is from say node N2 to node N4, because they are okay connected with each other, in the sense they are in the range of one another. So you can have a data transfer either from N2 to N4 or vice versa. So I wanted to transfer data from say N4 to N2. Then you have to add the source agent type to the node N4. So I'm going to take the source agent type as say TCP. Then I have to add that okay TCP to this node. So this is the sender. This is the agent type at the sender. So you have to take the agent type at the receiver side. So this is the receiver. I am adding the agent type, that is a sync, and I need to establish a link between the agent types. Okay, that is a TCP2 and sync. After this, you can add the application types to this agent types. So I am taking one of the application type as a, here both agent types are TCPs, therefore you have to take the application type as FTP, and if you want to have change in the start and stop time values, you can have. So for the first data transfer, I am taking the start and stop times values as 1 and 2. So I am adding this agent type, this agent that is FTP to this agent type that is a TCP0, which is connected to the node that is a N0. And I wanted to take the same application type, and I want to change this start and stop time values. So you are known that first agent is transferring data from first unit of time to the second unit of time, and I wanted to have this second data transfer from third unit of time to the fourth unit of time. I want to keep idle from second unit to third unit. So I am going to take the start and stop time values as 3 and 4 respectively. After this, you have to attach that application type to the second agent. Your second agent type is that is a TCP2. So for that, right, I am connecting this application, that is FTP1, and then so here the in two data transfers I have taken the start times as 2 and 4. Therefore you have to take the simulation time as 4 or more. So when you click on this, parameters, you have got a new window. In this window, here you have same as that simulation time, trace file and YAM file. But in addition to this, simulation, you will have other fields in case of this wireless network, namely that is wireless and channel. So before, first you can go to this wireless channel, and here if you want to make any changes, so these are the fields you have: channel type, propagation model, protocol type, link layer type, etc. And if you want to have change, if you want to change this routing protocol name, you can change. We have different types of routing protocols: DSDV, DSR, AODV. DSDV stands for dynamic sequence distance vector. DSR stands for dynamic source routing protocol. AODV stands for ad hoc on demand distance vector. And this TORA, it stands for temporally ordered routing algorithm. So you can choose any one of this. So I am taking this DSDV itself. After this, you can just click on and when you go to this channel, you just verify what is there in the channel. So here also you have some base, some other fields like bandwidth, and if you want to make any changes for these values, you can write. So if you make the changes, you just click on done. So this is the wireless. I have not routing protocol DSDV is selected. So if you want to make any changes in that, what is there in a channel? Wireless channel, that is a DSDV. If you want to have itself, you can have it, otherwise. So I want to make a change to DSR, so you click on, at last you can click on this done. So I want to take this transmission time as say 6, or say after this you have to give the trace and name file for this. I want to give the name for this file as this is a wide network one, so I am giving the name as say not wide network, it is a wireless network, so I am giving the name as wireless network, WLN. Say let me give it as a 1, wireless network 1. So you have to give the same name, whatever you have used for the trace name, you have to use the same name, wireless network 1, and that dot must be there, which is separating both. That is the extension. So after this, you just click on done. If you just click on done, this is going to get completed. And this is script for this. just save. You can save it on desktop. Your name is WLN1. Extension must be TCL and click save. So once again you can just save and you can exit from this. If you want to go through this wireless network, you can go through your known. You have two data transfers, that is from N4 to N2, N4 to N2. So it is N2 to N4. Let me take a screenshot of this. So it is going to help us in recalling what we have done. Yeah, you are known, you are transferring data from node N0 to N1, and also you are transferring data from N2 to N4. Yeah, so you just save. Already have saved. By the name. So these are simulation parameters set up. Same as that. These are output files, and then before that you'll have declaration of the simulator, and then agent definition, application definition. It is same as that in wide network. So you just save and exit. Let us confirm. So if at all it is here itself, you can give it as a .tcl. See, now it has got the name as win1 .tcl. So now it is perfectly saved. After this you click on the system and you can click on exit. So you can check whether that file is created or not. So if you display the list of files with extension TCL, you can find that star.tcl. So is there a file name by name WLN1.tcl? Yes, it is there. So this is that file. I have not yet created this. I have not yet executed this. So you don't find trace and okay now files okay with this file name, because so let me check this better. Trace file, so is there a file name WLN1? So you don't find that because it is not yet executed. Okay, I have not yet executed that, so you don't find even this name file also by the name WLN1. So you don't find anywhere that file name that is WLN1. So when I execute that file, what is the command? ns space WLN1 dot TCL. It is going to get okay executed. So is this the network okay that what I have created? Yeah, if you want to okay edit, you can edit. If you want to zoom in, you can zoom in like this. So now I think you can clearly see this. So this is what the network, right, that what I have created. So in the animation okay window, you don't see the links okay between the nodes because it is like a wireless network. So you just start the simulation by clicking on this okay play button. You are known that you are okay transferring data from first unit of time to the second unit of time from node N0 to N1. So when it reaches right now that is 0.8, when it reaches okay 1.0, the data transmission okay will start at node N0 and it will get okay transferred to the node N1. Okay, watch carefully. So can you see that okay line? So these circles they indicate that there is data transfer. This is the there is a data transfer is okay taking place between the nodes. So you are known how long you are transferring data from first unit of time to the second unit of time. So when we reaches this okay second unit of time, it is going to get okay stopped. So it has got stopped. And second data transfer okay will start at okay third unit of time and it is going to get stopped at okay fourth unit of time. So 2 to 3 from second unit of time to third unit of time there is no transfer of data, so it is not okay taking place. So right now the time is okay 2.6. So when it reaches okay 3.0, the data transmission second data transfer okay will takes place, that is from node 2 to 4. You are known that, right? So in the design, so you just continue. So now it is about to reach 3. So the second okay data transfer has been started okay from second unit from the node N2 to node N4. See, how long you are transferring? Till fourth unit of time. So now it is okay 3.8. When it reaches 4.0, it is going to get stopped. So you just continue, and I have given the simulation time as 6. So when it reaches 6, it is going to get stopped. Simulation is going to get stuck. So it has reached okay, 4th unit of time. So it has got okay stop. And the simulation is going to be okay gets ended at okay 6th unit of time. So the simulation is okay ended at 6.05. 6.05. Now we analyze the quality of okay service parameters in the okay wireless network. So these are the quality of okay service parameters with respect to this wireless network, that is a delay, packet drop and throughput. So let me close this and go to the terminal. You can just okay press enter, and if you want to clear this screen you can. After this you are known the name of the file. If you want to see the okay contents of this trace file, you can see. You are known right what is the command gedit. Name of your file is WLN wireless network 1 dot trace file. So you have to use the extension as okay tr. So these are the contents of your trace file. You are known that in the case of okay wide okay network, okay, there are some 12 fields, right? In a similar fashion, in the case of okay wireless network also you will have okay some number of fields. So this is the event, this is the time, this is the okay application type, then flags, that is a from node, okay, packet size. Like this you have of fields with respect to this trace file in case of this okay wireless network. And you are known okay if you want to open directly this NAM file, the command for this is NAM space what is the name of your file, that is a WLN1 dot NAM. This is the okay command for that. So directly you can open that okay NAM file. So this is the NAM window. You can see that network. Next, but we are okay mainly interested in analyzing the quality of okay service parameters of this wireless network. So what is a command for that? By using awk files, okay, awk hyphen f yeah, these are okay wireless networks. So for throughput there is a awk file by name thro. If you want I can show the contents of those awk files later. Yeah, this is a awk file step for finding the okay throughput. awk throughput dot awk, and then uh, trace name of that wireless file. Your known trace name of that wireless network is ln1.tr. So whenever you are using this, whenever you are analyzing the quality of service parameters using this AWK, how to use the trace file name. So this is the trace file name. So you just have to click on that. Yeah, there is a spell mistake. Whenever you get some error, don't be scared. You just go through the information that is displayed. So by means of that, right, you can easily come to know. So these are the throughput values. See, these are the throughput values. You are known that all data transfers are going to get ended at 4th unit of time, and your simulation gets ended at 6th unit of time. So this is average throughput. So in the bottom you have that average throughput. So this first column is time and this is the throughput. So at 1.0 this is a throughput. So for every point 1 millisecond, you can have this throughput values. See, 0.08, 0.09, 0.6, like this. So for every 0.01 millisecond you have this throughput values, and in the bottom you have that average throughput. So whenever you are, so this is a start time and this is the stop time. Your the data transfer is ended at 4.31 unit of time. So whenever you want to make a comparison between different routing protocols, so without changing without making any changes, you can just change only that routing protocol name and you can find the throughput values, so that you can have a comparison between the routing protocols. So in using which routing protocol you are getting a very good throughput like this. So this is about throughput. In a similar fashion, we have other quality of service parameters, namely that is a delay. So the command for that is this. So I have written a script in the file name that is delay, for finding the delay in the wireless network. So if you just change the name of that AWK file, that will be enough. So this is the delay you have got, that is 0.15, and this is the control overhead. So this time I wanted to find the control overhead. So the name of the AWK file is, that is a CO, control overhead. Just press enter. So this is number of data packets and routing data packets. Your normalized routing load, that is control overhead, is routing packets divided by data packets. So 0 by 160, I have got it as a 0, like this. In a similar fashion, you have other quality of a service parameter, namely that is a packet drop. So you just change the name of that parameter in which what you are finding and what is the script of that name of the script file in which you have written the code, okay, in order to find further. So you just press enter. So the number of dropped packets is that is a 0. So this is how you can find the quality of service parameters. So if you want me show the content of this AWK files, let me show one of the file. So gedit control overhead, right, dot the name of extension is that is AWK, gedit co.awk. So this is a code for them. So in a similar fashion you can have other scripts. So this is what about creation of nodes and transfer of data in the case of this wireless network. I think you have understood it very clearly. How to create the nodes and how to transfer data and how to analyze or say find the quality of service parameters. Now we will see the mobility of nodes in the case of wireless network. So how do you provide the mobility to the nodes in the network? So I'm going to create a new scenario. So let me clear this. Java space hyphen jar space nsg 2 dot jar. Press enter. A window will get opened. A new window. So here you have to select the scenario. We are working on wireless networks. Therefore you have to select new wireless scenario, and then I am creating a one node. So right now this node, the field node is active. Under this you have this already I have discussed about all these things while I was discussing about wide network. So first let us see how to provide mobility for one node. Later we will see uh, mobility of two or modes. So this is first. I'm going to create one and only one node at first, and I'm going to provide a mobility for that node. So whenever you create these nodes, at the time of providing mobility to the nodes, this x and y coordinates of this nodes information is going to be helpful as. So I have noted, you can say that its values, that is 450 and okay 245. So I just want to have the okay mobility of the node, right? So you don't need to okay do anything, directly you can go to this okay parameters. So here you have simulation wireless channel. So you can, you need to add the code in the okay script file itself. Here we can't add that, so first you can take okay any time, say 3 or 4 unit of time. Simulation time I have taken it as a 3, and trace file and okay nam files are, you are known that name must be the same. So this one, this time I am using the name as a wireless network 2 dot tr. Wireless network 2 dot nam, and I am not going to make okay, any changes with respect to other fields under okay wireless and channel. I am taking this okay default values itself, and if you want to have okay any changes okay for that, you can have. Whenever you make the change, you just okay click on this done. So in the simulator you have given this, right, win2, this is the trace and okay nam file. So you finally have to okay click on this done, and then you can go to this script. So this is the script. So if you wanted to go through the okay, script, you can go through. Here you can have information, what is the range of this x and okay y coordinate. The range here is what 550 and okay 345. So within that only, right, I have to take the 345, that is simulation time. Link layer, here we are using the queue mechanism as a drop type interface okay queue type if. So now we are interested in mobility of the devices, right? So how you are going to provide that mobility? You just need to this is the topology. So after this okay nodes definition. Yeah. I have not added any agents or applications, therefore you don't have this okay information. So this is the information about node, that what I have created. You have created a node N0 with x and okay y coordinates as 450 and okay 245, and the range of this node is yeah, here you can see 550 and 345. So maximum value that you can take for this x coordinate is 550, and the maximum y coordinate, while you are providing mobility to the node, you can take the value as that is a 345. So you have to make a note of those values. After this, there is a one. So to how to add this, how to provide the mobilities like this, dollar ns at at dollar ns at space at what point of time you want to have mobility of the device, say 1 unit of time, then you can take it as say 1. You have known that you have taken the simulation time as a 3, right? So at 1 or say 1, so otherwise at 0.5, because we have taken the less simulation time at 0.5. For what mode you want to have the mobility? Dollar n naught, dollar n naught, set dest, set dest. So you are known what are the x and y coordinates. X and y coordinate is, x coordinate is 450, so its range is till 550. Therefore I can take its value as say 525, for example, 525, right? And then y coordinate, it's 245, its range is till 345. Therefore I can take it as a 340. And then you have to mention the speed, with what speed, right, it can move. So I'm giving this movement value as say 40, for example, 40. That's so you are moving the node n0 at 0.5 time to this position with the speed that is a 40. So I have to give a space here. Let us first execute. After this, if you want to make any changes for that, you can change. So save this code. On desktop. You are known, the name of your file name is wireless network 2 dot tcl. Here itself, if you want to give the extension, you can save. It has got save. See, I've got the name as win2 wln2 dot tcl. So once again you save and you can close this. You can come out of this. Now you can execute the command. So if you want to check whether that file, whether there is a file by name that is wln2.tcl or not, you can check. So for that, what you need to do, you are known .tcl. So is there a file name wln2? Yes, it is there. That is the tcl file name, and I have not yet executed this, so you don't find trace and name files with that name. So let me show now. Is there a nav file wln2, you don't have C. You have ln1 but not okay ln2 because you have not yet okay executed now, right? After this you are supposed to have that. Yes, that okay you don't find. Yes, you have not yet okay executed, you are not okay finding that. So right now you don't find even this okay trace file as well as you have not yet executed. Can you find? No, you don't find it because you have not yet executed. You have, see, if at all if it is there, after this you are supposed to have, right? ln wln2. You have only ln wln1 but not wln2. So because of the reason we have cannot yet executed. So this time I am going to execute. So when we execute, so what is the command? ns space. The name of your file name must be what? That is wireless network, that is a 2 is TCL. You can just press enter. So a window has got opened, okay, animation window. So this is the node. Can you see this or you want me? You can okay have the adjustment. Yeah. Yeah. Now you can start the simulation. So for that you are known, right, at 0.5 time, right, the moment of node, okay, it is taking place. See, I have started the simulation. Now the time is 0. Yeah, 5. So the movement of node it is going to get started because the time is 0.5. We just watch carefully whether the, so can you see that is the node is moving? Yes, it is moving. You can watch that. You have mentioned the position, no? So to that position it is going to get moved. 550, 345. You need to adjust this simulation time and data speed if needed. So this is how you can add mobility to the nodes in the wireless network. I think you have understood this. So if you want to make any changes to the code, you can. If you want to increase this simulation time, you can increase the command. First you can open that file, wireless network 2.tcl. So change this value from 3 to say 6. If you are doubtful that whether the node reached its desired destination or not, okay, because still it was under motion, okay, so that is movement, so we were doubtful. So otherwise Yeah. More than that also you can take. I think speed, okay, you can okay clearly observe. If you want to increase the speed, okay, you can increase. So earlier I have taken the speed value as what? That is a 40. If you want to okay change it, okay, say from, if you want to okay change, that is from say 40 to okay 60, you can change. Only once you are going to make a change, and later on you are going to make a change in the script itself instead of okay scenario. So this is what this. So you just okay say, just okay click on save. Yeah, this saved. Close this and you can execute right once again. ns space into. If you want to make okay any changes, you can okay move or up or down. So you can start the simulation. Just you are known that the moment okay it starts at okay 0.5 unit of time. So right now 0.4, when it reaches 0.5 it starts. See, it has started at okay 0.5 unit of time. Given enough simulation time, so still it is moving, you can see. To its okay desired destination. This time I have increased the speed as well, you know. So it has reached its destination. So at 2.7th unit of time itself, okay, it has got stopped the movement. So in the sense, it has reached its desired okay, destination. So you can increase the speed. So earlier I have given simulation time as 3. So this time I have increased that okay, simulation time. You just I have taken the value as I think 8. So till that time you just need to wait for that. That's so this is what about the mobility of a single node. In a similar fashion, if you want to have mobility of 2 or more nodes, right? You can have like you can have the mobility of nodes from one place to the other place. In the sense, suppose if you have say 3 nodes, n1, n2, n3. If you want to move the node n1 to the n2 position, you can have. And if you want to move say n2 to n1 position, you can have. That is, if you want to interchange the okay, positions of the nodes, first of all, you must be known about the x and y coordinates of those nodes. So if you want to interchange the positions of the nodes, you can have. So in a similar fashion, whatever for the other node, right, if you want to have a movement say in another direction, say that is to another place, right, you can have. It is up to you. So this is what about mobility of the nodes in the network. I already discussed about quality of service parameters with respect to the file WLN1. So I don't want to explain the same thing once again. If you want, I can show the mobility of two or more nodes this time. So for that, what you need to do, java space -jar space nsg2.jar, enter. Click on this scenario, new wireless scenario, nodes. This is like a first node, and this is like a second node. So they are not in the range of one another. If they are in the range of one another, you can have the intersections of these circles. You know, this circle represents the range of the node. So first let me record the x and y coordinates of these nodes. You are known that you have two nodes n0 and n1 whose x and y coordinates are 355, 258 for node n0 and 868, 260 respectively are the coordinates of nodes n0 and n1. So after this, I'm not doing adding any agents or applications. I just wanted to have the mobility of the nodes. So directly can go to this parameters, and you can take the simulation time as say 10 itself. And if you want to have any changes, right, with respect to the values of any other fields, you can have. After this, you can give the name of the file. So wireless network 3.tcl. This time I am giving the name of the file as 3. So you just click on done. So go to this script. I told you in the script only you need to add this mobility. In the scenario we can't do that. So where you are adding this information, you are known that under this nodes definition. And before that, you must be aware of what is range of this x and y coordinate. The range for this is what? 968, 360. 968, 360. But in fact, I am interested in interchanging the positions, right? Even the range of these values are also not needed, so that whenever you are transferring data, in that case only you need okay these values, otherwise you don't need. So yeah, no, I'll cancel this. I have not yet okay added the okay mobility to the nodes, so I'm doing that part. Just I have created two nodes in the simulation, so we have to do that. No problem. By mistake it has got closed. Wireless scenario. This is the first node, and this is the second node. Once again you need to record these values because coordinates are going to be different. So what are the x and y coordinates of the node n0, 441 and 179 respectively, and a node n1, 1066, 1511. 151, that's 1066, 151. That is right coordinate. Okay. Go to parameters. So let me take the name as WLN 4. WLN 4. I have not made any changes with respect to any other fields. So if you want, you can just go through. You are using the DSDB. Packet size 50, like this. Agent, yeah. These are some fields you have. I'm not making any changes. Just I'm showing you DSDB I'm using. Simulation. And then just click on this done. I will use this file name as Win4, WLN4. After this, click on this TCL. You can get that. You have to use that same file name WLN4. After saving, you can open once again and then make the changes. You can change if you think that you may forget. WLN4 you have to use .tcl. WLN4, right, on desktop. So you have to make sure that you are saving your file on desktop itself. So it has got the name as WLN4.tcl. So now if you want to make any changes for this code, you can change. You know its range is 1284 by 100. 1284 by 100, but I just I'm noting down. Simulation time is 10. Make a note of that. Simulation time is 10. So what is the command for that? With respect to single node, you have seen no? $ns space at what, say at 1.0 unit of time I want to start movement. 1.0 in the double quote space dollar. So to what node you want to have the movement? Okay, n0, right? N0 set, no space between, okay, set and dest, set to destination. So you want to move the, okay, node n0 to node n1 position, right? You are known what are the x and y coordinates of this nodes, okay, n0 and n1. So here these are the nodes of the node n0 and these are the coordinates of the node n2. So I want to move node n2 to n0 to n1 position. So you are known what are the coordinates of this n1 node, that is 1066 and 151. Here you can see these are the x and okay y coordinates, therefore I have to use that values. Yeah, what I have to give? Yeah, 1066 space y coordinate is what, 151 space. You have to give the, okay, speed, with what speed, right, you wanted to have the movement. So I am giving the speed as say 50, and then you have to give the space double quote. Space is also mandatory. So this is okay, one movement, and I am adding the second movement, dollar ns at what time you want to have data transfer, say 3.0 for example, okay, 3.0 after with a time gap of, okay, 2 units, right? I want to, okay, transfer or start movement of, okay, second move, okay, dollar n1 set dest. You are interchanging the positions of the nodes. You are okay, moving n0 to n1 and, okay, n1 to n0. So what are the coordinates you have to use? You have to use the coordinates of what? Node n0. You are known what are the x and y coordinates of the node n0. So these are the x and y coordinates of the node n0. So you have to give those values. So 441 space 179. So after this you have to give one, that is the speed. So with the double of that speed or say half of that speed, you want, yeah, with the half of the first speed I want it to move, so I can give the speed value as say 24. So like this. Only this part, right, how to do that. I think I understood. So you just say after adding, okay, these lines and, okay, come out of this and execute your program. You are known the name of your file is wln4.tcl. So there is dollar, yeah, let me, okay, go to the code. You have got some, okay, error. So gedit, name of your file is wireless network 4.tcl, right? So with respect to this code I have got some error. Let me see. Dollar ns dollar n0. You should not have any space between this dollar and node name. That is the error we have got. control here. You can just save. Your node N0, it is starting its movement at 1, and node N1 it is okay starting its movement at 3, right? So I have made the changes. Yeah, now it is working. Close this. Now once again can execute this. N is yeah. So if you want to have the mobility of the nodes or say transfer of data, the nodes must be in the range of one another, and you are known that the nodes that whatever I have created, they are not in the range of okay one another. Therefore, right, you are getting this okay problem. So just to make okay aware of that, I have created the okay nodes okay in this fashion. I think you understood right what will happen if you create the nodes which are not in the range of one another, and when you try to transfer data or create a movement of node, right, what will happen? So this is what is going to happen. So let me okay firstly complete. Now I have become okay familiarized. Once you become okay familiar, it doesn't take okay much time. So this is the first node, and this is the second node. Parameters. I'm giving the name as wireless network 5. Wireless network 5.name. I'm not making any changes with respect to any values. So from I can okay note a note of these values 335, 245. Anyhow in the code also you can script also you can find 560, 260. 560, 261. Go to TCL. So you have got the name as so here I have to add the code $ns at what time you want to have okay at 1 unit of time, okay, 1.0 or say 1.0 set dist the double quote dollar n 0 space set. Between set and dest there is no space. Set dest. You are known what are the x and y coordinates. Here you can observe. You are moving node n0 to node n1. Therefore, you have to take the value says okay 560, 261, 261, and then you have to mention the speed, say 50, and then double quote. Here also you need to have the space, but between and dollar, yeah, you cannot have the space. Dollar ns at 18.0, because I have taken the time as space dollar n1 space set dest. You are known what are the x and y coordinates of the node n0. 335, 245. 335 space 245 space speed. I am increasing the speed, say 75 space. Yeah, this is what the code. And here you need to have the space. No space there. Yeah, that is correct. Yeah. Save this. Save on desktop. What is the name you are using? WLN5. WLN5. Save. WLN5. Yeah, it's correct only. After this, once again save on exit and execute that command. On this LN5, right? I have changed the file name. So it has got executed. It is getting executed. This is, you have to be careful. You are moving node okay n0 to n1 position and n1 to n2 position. You are known that. If you want to have this adjustments, you can have. Now you can start the simulation. You click on this OK play button. You are known 0 is starting its movement at 1 and 1 is starting at third unit of time. If you want to increase the speed, okay, slightly you can increase. So at 1 unit of time, right now that is 0.8. When it reaches, when the timer reaches 1.0, node N0 will start its movement. You are known that, right? So watch carefully. We are about to reach okay 1.0. So see, node N0 is slowly moving. Okay, I have not mentioned right any end time for that because we don't know that how much time it is. So one more thing, your second node, that is N1, okay, node that is 1, it starts its movement at okay third unit of time. So we are about to reach, right now we are at okay 2.5, 2.4. When it reaches, it also starts its movement. So from third unit of time you can have the okay movements of both the nodes. You see, the second node, it has okay started okay its movement. Now they both are moving to one another place. We are swapping the positions of the nodes. See, but their okay data transfers rates are different. Node 1 is moving okay little bit okay faster than node N0 because I have taken the speed for node 1 as 75, for node N0 as 50. See, node 0 already has reached its destination. So now node 1 also has reached its destination. So I have given the simulation time 10. So till then you just need to wait. That's all for today. Thank you so much for listening so patiently and watching my video. We will meet in another video with a different topic. Till then, bye bye. Take care. See you again. Once again, thank you so much. Already ఉంది రికార్డు వస్తుంది.
అవి అర్షిత జగ్గులో నీళ్ళు ఉన్నాయి కదా